Okay, so we're going to talk about our second of our three basic laws. So we are going to talk about the law of definite proportions. And so it says here that a single chemical compound. So the chemical compound I'm going to use in my example is going to be water. Okay. And it says it contains the same elements. Okay, so water, no matter if we're looking at it as a single water molecule, has two hydrogens and an oxygen, or if we're looking at a glass of water, there are still two hydrogens for every one oxygen. In the same proportions by mass, regardless of the size of the sample or the source of the compound. So in other words, it doesn't matter if I'm looking at that single water molecule or that entire glass of water, the ratio of hydrogen to oxygen in my sample is always going to be the same. And if I went and got water from your house or my house, again, the sample of water would still contain the same percentages. At some point this year, we'll talk about how we determine our percentages, right? But for now, I'm just going to give them to you. Okay, so if I have water, we can see this water molecule has two atoms of hydrogen, and it has one atom of oxygen. And so if I have 100% water, 11% of that would be my two hydrogen atoms, and 89% of this would be my one oxygen atom. Now, we could assume that we have a 100-gram sample. So if I have 100 grams of water, that would mean that 11 grams of my water would be the hydrogen, and 89 grams of this would be my oxygen. So from this, we can actually make our own conversion factors. We could make a ratio of hydrogen to oxygen. And so we could say that for every 11 grams of hydrogen, there would be 89 grams of oxygen. We could make a ratio of hydrogen to water. And so we could say that for every 11 grams of hydrogen, we would have 100 grams of water. And we can make a ratio of oxygen to water. And for this, we would say for every 89 grams of oxygen, we'd have to have 100 grams of water. So we can actually use our ratios to solve some problems. So I have 100 grams of hydrogen and it's combusted. So combusted is just a type of chemical reaction. It's really when it reacts with oxygen, so we're burning something. And I want to know how much water can be produced. So we've used dimensional analysis before. We know we're going to start with the number and the given in our problem. So we're going to start off with this 100 grams of hydrogen. I'm going to make my railroad tracks, and we can put my grams of hydrogen over 1. That 1 would simply be a placeholder. It does not have any units. And we're going to have to get rid of those grams of hydrogen, so it's going to go on the bottom of my railroad tracks. And what I want to know is the amount of water. So this means grams of water are going to go at the top. Okay, so if I go up and look at my conversion factors, we need one that has a ratio of hydrogen to water. And so here's my hydrogen to water. Okay. All right, now we got to match the numbers to the right unit here. So if I'm looking for hydrogen, then the number that goes there for hydrogen is 11 grams. So we're going to have an 11 here. And water There's 100 grams, so this means we're going to have 100 grams here. All right, so we would multiply across the top. And then we would multiply across the bottom. And we would divide. So we are to assume that this 100 grams of my hydrogen here is a measured value, so maybe I should actually put a decimal in here. And so this is going to have 4 sig figs, so I get, or 3, I'm sorry. So I get 45.5 grams of water as my final answer. Okay, so that's the second law of the 3 basic laws.